University of Exeter has got a very ambitious target of reducing our carbon emissions by 43% by 2020. This forms part of our low carbon commitment for the campus for the future. The Cornwall House project is a major part of this initiative and takes an old, inefficient concrete building and makes it a low carbon hub for the future.
The building was one of the leakiest that we operate. Every watt of heat that we poured into it was radiated straight out to the atmosphere through thin concrete panels, through leaky construction joints between the panels, through single glazed, drafty windows. So we took this on board as one of the key insulation issues, and the fact that we achieved an air tightness level that's twice as good as current building regulations was really encouraging.
We installed these thermally efficient windows under the project. These windows allow in 80% of the natural daylight whilst only releasing 20% of the energy, saving on air conditioning and heating costs.
The building, a 1960s prefabricated concrete building, is not unusual across higher education estates in the UK. That was the reason for choosing it for the upgrade project. And the fact that it started off with an energy rating of G, and after refurbishment we managed to achieve an energy rating of C, is really encouraging.
As a multi-use building, it's important we involve the staff and the students and the end users in the project. This ensures that there's some personal involvement in the project, and hopefully they can take this through to their future outside of the university.
There's lots of music practice rooms that people can use whenever, and it's good for dance groups. It has a variety of purposes.
Because of the wide variety of uses in the building, everything from a swimming pool to a bar to a laundry, we've had to undertake a number of different ways of cracking the egg. So, for example, we can switch off the bigger lights and just use the smaller cleaning lights as we need to. We've also included low energy light bulbs and automatic presence detection for our lighting systems too.
So we come here in the evenings on a Saturday night, so we don't have to go all the way into the clubs in town because they hold event type things here, so you can come in the evenings, which is good.
Part of the design process was using technical tools such as infrared photography and thermal modelling. These processes were of interest to some of our courses, such as engineering. So the design team and the estate professionals ended up lecturing to a few taught programmes, and our project was used as case studies on a few PhD research projects.
An innovative solar thermal system has been installed as well to generate hot water for the laundry demand in the building, but also when that's satisfied, the heat is then exported to the swimming pool.
As part of our multidisciplined approach, we can now look at Cornwall House and see how far we can take it. Can we make it a zero carbon building?
Prior to the project, the pool cleaners were set with this position that they couldn't turn the lights on or off because the light switches were unfortunately behind the bar. So as part of the project, we provided a new lighting control for them here so they could switch it off as they wanted. We also provided combined temperature and CO2 sensors so that we could vary the speed of our ventilation systems depending on how many people were using our facilities.
The Cornwall House project demonstrates how we can take inefficient buildings and make them fit for a low carbon future. This is demonstrated to our funders and our council members that we can do this for a lot more of our buildings on the campus.
These old energy inefficient boilers are given a fantastic new lease of life with these energy efficient burners to closely control the heat requirements on the heating circuit around the building. The entire 1960s concrete frame building has been completely overclad with 150 mil of insulation like a big warm duvet.
We believe the Cornwall House project has wider implications than just here at the University of Exeter. The findings have relevance for industry and others undertaking similar projects in old and inefficient buildings throughout the UK.
We're coming to the end of the first 12-month period post-refurbishment now. We've carried on our engagement with the occupants and users of the building. We've also carried on our monitoring of the energy performance of the building. Our predictions for carbon savings have turned out to be about right, and that is 200 tonnes of carbon per year, which relates to a saving on utility bills of about £38,000 per year. Those savings will be ongoing and hopefully increased over the next years as we engage more with the occupants and try and take the building to the next level.
If we were to win the Green Gown Award, it provides recognition for our low carbon commitment and demonstrate to HEFCE, our funders, what could be achieved with their support.